Hello, in this video I'm going to solve this checkpoint problem. Let G be a group and let A and B belong to G be elements such that BAB inverse is equal to A to the mth for some integer m. It might be positive, negative, or 0. Show that for every natural number n, b to the nth, a, b to the minus nth, equals to a to the m to the nth. So we want to prove this. Pause the video at this point and give it a try. Okay, so now let us solve this problem. So I want to use mathematical induction on n to prove this. But before doing that, let me just remind you a little bit about this notation. Let us go back to high school algebra. And let me write 2 to the power of 2 to the power of 3. And then this is just forget about this problem for the time being. And then I have 2 to the power of 2 to the power of 3. So I want you to understand the difference between them. So here, if I ask you what do you have here, you will tell me that I have a power, because you know that any expression of this 4 is called the power in mathematics. And if I ask you what a is, you will tell me a is the base, and what n is the exponent. So if I ask you the same question here, you already know the answer. If I ask you what is this, you will tell me it's a power. If I ask you what is the base here, so the base here, which is playing the role of a, you will hopefully tell me it is 2 to power 2. And if I ask you what is the exponent, you will tell me it is 3. And if I ask you the same question here, I want you to know, if I ask you what is the base here, this is your base. And if I ask you what is the power is 2 to power 3 itself. So here, the exponent is 2 to power 3. So the exponent itself is another power. So if I ask you what is the number here, you would say that this is 2 to the power of 2 times 3 is 6, which is, 64. But if I ask you what this is, you have to do this one first, because if you want to calculate the power, you need to know the exponent first so that you multiply that by that exponent appropriate number of times. So this becomes 2, and this one is 8. And then it becomes 256, and you see that the answers are quite different. So the one we are using in this problem is of this type. So in other words, if you see a to the power of m to the power of n, this in principle means you have to prioritize this one. So I'm putting a pair of brackets around that. So I want you to understand first, what does it mean? Okay, now forget about these and let us go back to our problem. I want to use mathematical induction to prove it, but how can I do that? The first thing, I want to make sure that this is valid if n is equal to 1. So I want to check for n equals to 1. So I replace n with 1, so it becomes b to the power of 1, which is b to power minus 1 is equal to a to the power of m, but m itself is raised to power 1, which in this case becomes m. Okay, is this true or false? How should I know? I know it is true because of the assumption given in the problem related to this integer m. So that is true. But for the next part, I would assume that, let us assume that this is true for n equals to k. So in other words, if I replace n with k, this one is assumed to be true. But I want to prove that this statement for the next n, and k plus 1, is also true. So n equals to k plus 1 means what? I replace n with k plus 1 everywhere. So be careful, you have to put a pair of brackets because I replace n with k plus 1, and this minus sign is an overall minus sign. And then on the right hand side, I will have a to power n to power k plus 1. Okay, so to be proven. Yes? So this is the one that I want to prove. But I am not empty-handed, so that is the strength of mathematical induction, you are not empty-handed. You actually have something you can use. Okay, so what I can do, I want to prove this one. I will start from the left side of this equality and then go to the right hand side, and I will use the assumption. Okay, so what I do, I would say the left hand side is equal to b to power k plus 1. Let me copy and paste everything quickly, and let me put this minus sign in, and then a to the power of m k plus 1. Okay. Oh, sorry. Let us not write this. I want to continue and reach to the right hand side. Okay, but how can I do that? This is what I have. I want somehow to use this there. So this is b to the kth, and this is b to the minus kth. But either I have 1 unit here and minus 1 unit there. So if I want to use it, it is not hard to see. Let us write it in a way that I can use that equality. Of course, I can write it, so b to the power of k plus 1 can be written as b times bk. It can also be written as bkb. Which one is suitable here? If I write this one, then b goes close to a. If I write this one, then b to the kth goes close to a. Which one is suitable? The one that b to the kth is close to. So you choose this one, even though this is also true, but it is not useful. This one is true and useful, this is true and useless. So we choose true and useful. So then what happens here, this becomes b to the power of k, and then I would write it as am I right or wrong? So let me see. No, it seems correct. Okay. So what happens here? Instead, I thought that I have missed one power in the question. No, the question is exactly this one. So a, I copy and paste it here, and this one exactly, I'll write it as b minus k and b minus 1, even though I could write it the other way around, but this one is useful because of the combination I need here, yes? So then what happens, so this middle one, based on mathematical induction, I copy and paste b, I copy and paste b minus 1, but instead of this one, which I underlined here, I can use mathematical induction and write this. So it becomes a m to the kth. But if you remember what I told you in the lesson, so I can write it as b inverse to the power of m to the kth. So that is the tricky part here. So if you remember in the lesson, I told you that if you have a group element, whatever it is, sandwiched between a group element and its inverse, and I decide to raise it to any power, integer power, say m, then you don't touch b and b inverse. You just raise the middle one to that power. So this means this is the equality. Sometimes this is given, you need to write this. Sometimes this is given, you can write it in that way because that's equality. And I am using this to this because I already have. So this is playing the role of my box here, and this is playing the role of capital M. So I have b box to the capital M, b inverse. So I can write it b box, b inverse to the capital M. So that's correct. Okay? But then, what I can do here, okay, but now BAB inverse is given to me from the very beginning. It is a to the mth. So this means that instead of this expression, I can write a to the mth, and then I have to the power of m to the power of k. Okay? And then we have these rules, yes? So if I have a to power m to power n, if m and n are integers, we saw in the course that we can write a and multiply the exponents. So here, this is playing the role of capital A here. This is playing the role of capital M here. And this whole thing is playing the role of capital M. So this becomes capital A, which in this case is A. But m, this is little m, multiplied by capital N, which is m to the kth. Okay? So if I ask you what do you have, you will tell me this is a power whose base is A, but the exponent is this expression, which is a multiplication of two powers with the same bases and different exponents. So if I ask you what is the answer to this, the answer to this is m k plus 1, and then I have a as the base. So this becomes a to the power of m to the power of k plus 1, and that is exactly the right-hand side. Yes? Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.